You have discovered that an experiment is any movement that should be possible more than once under comparative condition. You got +1 on your performance task. Keep answering and aim to get the correct response. Take a picture and use a fan sign before proceeding to the next activity. Record your points in your reflection notebook. Another important concept in statistics that you've learned in Mathematics 10 is sample space. The arrangement of every possible outcome of an experiment is what we call sample space. You have additionally figured out how to mathematically list down the conceivable outcome of a given experiment. In tossing a coin, for example, the potential results are turning up a head or a tail. Random variable is another important concept introduced in statistics in Mathematics 10. In our given example, the number of blue candies is a random variable. It is a function that associates a numerical value with every outcome of an experiment. Its domain is a sample space, and its range is some set of real numbers. An uppercase letter, commonly X, is used to denote a random variable, while the corresponding lowercase letter x is used to denote one of the values of a random variable. A random variable has either a probability distribution for a discrete random variable or a probability density function for a continuous random variable. Let's call the next activity 1 peso. I want you to get a 1 peso coin. Can you identify who is in one side of the coin? On your reflection notebook, I want you to answer the questions. Do you know who is Dr. Jose P. Rizal? Can you give some of his great contributions? Take a closer look on your 1 peso coin. The side with Dr. Jose Rizal on it is what we call the head, and the other side, the tail. Please pause the video to do the following steps. You may express your answer using illustration, by listing, or using a table. Your answer can be posted in our group chat, or you can message it personally, or attach it in your answer sheet. Using the method that is most convenient to you, we found out that there are 8 possible outcomes. Getting 3 heads appeared once. Getting 2 heads appeared thrice or 3 times. Getting 1 head appeared 3 times. And getting no head appeared once. Pause the video to compute for the possibility of getting all heads, 2 heads, 1 head, and no heads. The possibility is denoted by P of x. To answer this, use the hint P of x is equal to the possible outcome, denoted by x, over the total number of possible outcome, denoted by summation of x. You may represent your answer using table, in graphical form, using problem, the probability of getting at least one head means a chance of getting a minimum of one head or a chance of getting one or more heads. In mathematical statement, at least is represented by greater than or equal to symbol. In this case, the probability of getting one or more than one head is the total of the probability of getting one head, the probability of getting two heads, and the probability of getting all heads or three heads. On the next problem, what is the probability of getting at most one head? The probability of getting at most one head means a chance of getting a maximum of one head or a chance of getting one or less than one head. In mathematical statement, at most is represented by less than or equal to symbol. In this case, the probability of getting one or less than one head is the total of the probability of no heads, of getting no heads, and the probability of getting one heads. In this activity, you were asked to complete the table by identifying the sample space of the given event and find the probability of getting one head. We were given here 4 events, but the third event was done for us because tossing 3 coins is the same as tossing a coin 3 times, which is our activity earlier. We are done with 1 peso activity. So the probability of getting ahead in tossing a coin is an example of discrete variable. A discrete variable is a variable which can only view as countable value. In our next task, let's find out which of the following events are countable like tossing of coins. To answer this task, we use a 3-column table. The first column is for the experiment, the second column is for the random variable, and the third column is for the type of random variable. Which among the 5 experiments have countable random variable? If your answer are experiments 1, 3, and 5, then you're correct. We call them discrete random variable. What can you say about the experiment that is not countable? How will you quantify the random variable? For experiments 2 and 4, they are not countable, but we can quantify them by measuring. They are measurable. Therefore, you call the type of random variable continuous random variable. It is not countable. How will you quantify the random variable? For experiments 2 and 4, they are not countable, but we can quantify them by measuring. They are measurable. Therefore, you call the type of random variable continuous random variable. Let's sum up what you've learned. Complete the following statements by writing the correct word. Pause the video while you answer numbers 1 to 5. Now let's check your understanding. 1. A variable whose value is obtained by counting data is called discrete. 2. A variable whose value is obtained by measuring is called continuous. 3. A variable that can be discrete or continuous is random. 4. Time it takes to get to school is an example of continuous random variable. Is discrete and which random variable are continuous? If your answer in number 1, number 2, or you may do the following suggested activity. Grade 11 students of Statistics and Probability for learning with me. Before we end this video lesson, may I share with you a point to ponder by Dr. Jose Rizal. And I quote, "One only die once, and if one does not die well, a good opportunity is lost and will not present itself again." Once again, thank you and God bless.